Have you ever wondered what lies beyond our blue skies, past the veil of clouds, beyond the reach of birds and planes? Today, let me take you on a journey through the vast and mysterious family of worlds that circle our sun. Like pearls strung upon an invisible cosmic thread, each planet holds a story of fire and ice, of silence and storm, of beauty beyond the grasp of imagination. If you're ready to explore the celestial wonders of our solar system, then take a moment to like and share this journey with others who dream of the stars. Let the voyage begin. The story of the solar system begins with the smallest of them all, a scorched and shadowed world clinging closest to the furnace of our star. Mercury, the swift messenger, dances rapidly around the sun in just 88 Earth days, locked in a gravitational embrace that scorches half its surface while the other half remains cast in frozen shadow. With no atmosphere to speak of, this rocky sphere is an echo of the solar system's youth, its surface marred by countless craters, silent records of ancient impacts from a time when space was more wild, more violent, more alive. Mercury is a planet of paradoxes. It is both searing and freezing, bright and dark, fast and strangely slow. Though it orbits the sun faster than any other planet, its rotation is peculiar. A day on Mercury, from one sunrise to the next, lasts nearly 60 Earth days. This strange rhythm means that for weeks, one side faces the unrelenting blaze of the sun, reaching temperatures hot enough to melt lead, while the other side remains locked in a frigid night, colder than any ice on Earth. There is no air to carry sound, no wind to whisper across its dusty plains, only silence deeper than silence itself. Mercury's surface is a storybook written in stone. The vast Calorus Basin, a colossal impact crater nearly 1,550 kilometers wide, bears witness to a time of chaos when newborn planets and asteroids collided like celestial marbles in a cosmic playground. Around it stretch cliffs hundreds of kilometers, long and kilometers high, formed as the planet's interior cooled and contracted, pulling the crust into wrinkled scars. These lobate scarps, as scientists call them, are the wrinkles of a planet growing old, a rocky face marked with the lines of time. Though small, Mercury is dense, its core is large and metallic, occupying over half its volume, suggesting it may once have been a larger world, stripped of its outer layers by a titanic collision in its formative years. This massive iron heart generates a weak magnetic field, only about 1% the strength of Earth's, yet it is enough to trap particles from the solar wind, creating shimmering bursts of energy around its poles. Even here, in a place without air or warmth or water, the dance of charged particles mimics the auroras of Earth in ghostly silence. There are no moons here. Mercury travels alone. It is too near the sun to keep companions. Its skies remain empty, save for the unrelenting glare of the star it orbits so faithfully. And yet, despite its harshness, Mercury carries traces of mystery. In deep, permanently shadowed craters near its poles, scientists have detected the faint signature of water. Ice, ancient, untouched, hidden in the dark folds where sunlight never dares to enter. How did it arrive here, in this desolate sun-baked corner of the system? Perhaps it was delivered by comets, those icy wanderers from the edge of the solar system, or perhaps it is a relic of the solar system's earliest days, preserved in deep time. Though no human has walked upon Mercury's surface, machines of our making have visited it. Mariner 10, in the 1970s, was the first to send back ghostly images of its battered terrain. Decades later, the Messenger spacecraft orbited Mercury, revealing it in detail never before imagined. The subtle colors of its mineral-streaked plains, the shimmering traces of volcanic activity long since stilled, the story of a planet that, though small and quiet, speaks with ancient, unyielding power. As we turn our eyes outward, past Mercury's shimmering path, we come to a world wrapped in veils, where the sun filters through clouds like a distant dream. Venus, the sister of Earth, nearly the same size, the same mass, the same gravity, and yet as different from Earth as fire is from water. Here, Beauty masks horror. A golden glow conceals an atmosphere dense with carbon dioxide, a thick blanket trapping heat with such cruel efficiency that Venus becomes the hottest planet in the solar system, hotter even than Mercury, despite lying further from the sun. Its clouds, pearlescent and radiant from afar, are composed of sulfuric acid. The air pressure at the surface is 90 times greater than Earth's, equivalent to being a kilometer beneath the sea. Any spacecraft daring to land here is crushed, melted, and silenced within hours. The wind howls at hurricane speeds, swirling endlessly in super-rotating tempests that encircle the planet in mere days. And yet, despite its rage, Venus once may have known peace. There are whispers in the data, hints that long ago oceans may have shimmered beneath its skies, that Venus may once have been temperate, habitable, alive. But something changed. Some ancient tipping point sent Venus spiraling into a runaway greenhouse state. Its oceans boiled away, its air thickened into poison, and its skies filled with acid and ash. Volcanoes erupted in fiery floods, reshaping the land in waves of molten rock. Vast plains of lava spread across its surface, burying the old beneath the new. And still today, there may be rumblings deep within. Some believe Venus still breathes, with volcanic heat, that its mountains may still smolder with the life of stone. Radar eyes from orbit have pierced Venus's clouds, mapping its terrain in ghostly outlines. They reveal highlands and valleys, coronae and pancake domes, the fingerprints of a geology both familiar and alien. There is Maxwell Montes, the highest mountain on Venus, rising taller than Everest, and the great rift valleys that carve through the planet's crust, like scars from ancient trauma. Despite its impenetrable veil, Venus has revealed its face in flashes, mysterious bright spots, unexplained glows, the suggestion of lightning crackling through sulfurous skies. Venus has no moons. Like Mercury, it travels alone, but with a presence impossible to ignore. In myth, Venus has always been the goddess of love and beauty, and her namesake planet glows brightest in our evening and morning skies. But this love is a dangerous one, a beauty that burns, a world that teaches us how delicate the balance of climate can be, how even a twin can become unrecognizably other. In the study of Venus, we learn not just about a distant planet, but about ourselves, our future, and the razor-thin line between paradise and perdition. And now from this world of fire and shadow we cross the celestial divide to a place painted blue and green, alive with movement, cloaked in clouds, and blessed with oceans that sing to the stars. Earth, the third planet from the sun, the only world we know to cradle life in its arms. Here, the story turns inward, toward a planet shaped not only by the forces of rock and sky, but by consciousness, by memory, by thought. But in the great story of the solar system, Earth is more than home. It is a miracle suspended in space, a whisper of balance in a universe of extremes. Earth, the jewel of the solar system, spins gracefully in the vast cosmic ballet, wrapped in a delicate veil of atmosphere that cradles every breath of life. Its surface is a mosaic of swirling oceans and sprawling continents, where water, a liquid so rare and precious in the solar system, shapes every corner of existence. The deep blues of the oceans meet the greens and browns of forests, deserts, and mountains, a tapestry constantly renewed by wind, rain, and the slow march of time. The atmosphere itself, a fragile blend of nitrogen, oxygen, and trace gases, protects this sanctuary from the harshness of space, filtering the sun's rays and shielding the planet from deadly cosmic radiation. Beneath this protective layer lies a world in motion, tectonic plates grinding slowly, creating mountains and valleys, opening new oceans and swallowing old ones. Volcanoes breathe fire from the deep, while glaciers carve cold rivers of ice over the land. Earth's magnetic field, born from a molten core of iron and nickel, acts as an invisible shield, deflecting solar winds and preserving the precious atmosphere that sustains life. It is this magnetic dance that gifts Earth with auroras, those shimmering curtains of light that grace polar skies in a breathtaking cosmic display. Life on Earth is a symphony of diversity, ranging from microscopic organisms flourishing in hidden niches to towering trees reaching for the sun. Over billions of years, life has evolved, adapted, and transformed the planet itself, painting the surface with the vibrant colors of forests, the delicate patterns of coral reefs, and the intricate structures of cities built by human hands. Every breath we take, every drop of water that falls as rain connects us to this vast, living planet, our only home in the endless dark. Yet Earth is more than its physical form. It is a story of balance and fragility. The delicate interplay between land, sea, and atmosphere creates climates that nurture life, yet can also unleash devastating storms, droughts, and wildfires. In the grand tapestry of the solar system, Earth stands as a testament to the extraordinary conditions necessary for life to emerge, a rare oasis in the vast desert of space. Our planet's story is entwined with our own, and as we explore the worlds beyond, we see reflections of Earth's beauty and mystery mirrored in distant spheres. Beyond Earth lies Mars, the Red Wanderer, a world of endless fascination and quiet desolation. Often called the Red Planet because of the iron oxide dust that coats its surface, Mars is a land of ancient valleys, towering volcanoes, and vast deserts. Though its surface is barren now, there is evidence that long ago, water once flowed freely, carving channels, filling lakes, and perhaps nurturing the seeds of life. The towering Olympus Mons, the tallest volcano in the solar system, rises 3 times the height of Mount Everest, a silent sentinel over a landscape that speaks of volcanic fury and geological wonder. Mars holds secrets beneath its rusty soil, frozen ice caps at its poles, dusty storms that can engulf the entire planet, and seasonal changes that hint at hidden water ice just below the surface. Its thin atmosphere, composed mostly of carbon dioxide, cannot protect it from the harsh sun or hold heat as Earth's does, causing wide temperature swings from freezing nights to chilly days. Yet, despite its harshness, Mars is the subject of our hopes and dreams. Robotic explorers traverse its surface, sending back stories of frozen riverbeds, mysterious methane emissions, and rocks shaped by forces both ancient and ongoing. The key idea of human footsteps on Mars captures the imagination, a new frontier where humanity might one day build homes beneath the stars. But the red planet's desolation reminds us of the fragile balance required to sustain life. It whispers of past climates, lost oceans, and perhaps lost possibilities. In the stark beauty of its barren landscapes, Mars invites us to ponder our place in the cosmos and the resilience required to reach beyond our origins. As we leave Mars behind, we enter the realm of the gas giants, where worlds made not of rock, but of swirling clouds and endless storms dominate the horizon. Jupiter, the king of planets, is a colossal orb of swirling gases and turbulent energy, the largest body in the solar system after the sun itself. Its atmosphere is a masterpiece of color and motion, bands of red, brown, white, and orange streak across its surface, driven by powerful jet streams that circle the planet at dizzying speeds. At the heart of Jupiter's ever-changing canvas lies the Great Red Spot, a storm larger than Earth that has raged for centuries, a swirling tempest of unimaginable power and mystery. Jupiter's gravity is so immense that it shepherds countless moons and captures stray objects, acting as a cosmic guardian to the inner solar system. Its magnetic field is the strongest of any planet, generating dazzling auroras and shielding its moons from harmful radiation. Jupiter's family includes at least 79 moons, each a world unto itself. Among them, the 4 largest, Io, Europa, Ganymede, and Callisto, captivate scientists and dreamers alike. Io is a world of fire and fury, dotted with active volcanoes that spew sulfur and ash, painting its surface with vivid colors. Europa's icy crust hides a vast ocean beneath, a potential cradle for life in the darkness beneath its frozen shell. Ganymede, the largest moon in the solar system, possesses its own magnetic field and a landscape of craters and grooves that tell stories of an ancient past. Callisto, heavily cratered and ancient, stands as a testament to the solar system's early days. Jupiter's grandeur is not just in its size, but in the profound influence it wields, shaping the architecture of our solar neighborhood and inspiring awe in all who gaze upon it. It is a world of extremes, where chaos and order dance in perpetual balance, and where the mysteries of planetary formation and cosmic evolution unfold before our eyes. Beyond the grandeur of Jupiter, the solar system reveals yet another giant, equally magnificent but cloaked in hues of blue and green, spinning with an elegance that captures the imagination. Saturn, the jewel of the heavens. Saturn is a titan, wrapped in rings, a spectacle of cosmic artistry unmatched by any other world. These rings, composed of billions of icy particles ranging from tiny specks to massive boulders, stretch out in delicate bands, shimmering with a brilliance born of reflected sunlight. Their graceful arcs and gaps tell tales of gravitational dances and ancient collisions, a celestial symphony frozen in time. Saturn's atmosphere is a swirling sea of hydrogen and helium, marked by storms that rage with fierce intensity and winds that race faster than any hurricane on Earth. Pale gold clouds drift across its surface, hiding deeper mysteries beneath. Unlike Jupiter's fiery bands, Saturn's clouds shimmer with a softer palette, whispering of gentler winds and quieter tempests, yet the planet is no less dynamic. Great storms periodically erupt, breaking the calm with sudden dramatic displays of light and energy. Encircling Saturn is a family of moons diverse and intriguing. Titan, the largest, commands attention with its dense orange haze, an atmosphere thick with nitrogen and methane, resembling an early Earth in its primordial days. Beneath this opaque veil lie rivers, lakes, and seas, not of water but of liquid, methane and ethane, flowing and pooling in frozen landscapes sculpted by the unseen forces of alien weather. Titan is a world both familiar and strange, where hydrocarbon rain falls gently onto icy dunes, and vast methane seas stretch toward horizons cloaked in perpetual twilight. Beyond Titan lie Enceladus, Mimas, Rhea, and countless others, each bearing unique secrets. Enceladus captivates with its icy geysers, erupting plumes of water vapor and organic molecules that hint at a subsurface ocean warmed by tidal forces. These jets reach into space, feeding Saturn's E-ring and offering tantalizing clues that beneath its frozen shell, life might yet find a refuge. The rings and moons of Saturn embody a delicate cosmic balance, a system of interaction and motion, so precise it defies simple explanation. They remind us that even in vastness there is order, and in beauty there is purpose. Saturn's grandeur invites contemplation, not only of planetary science but of the artistry that permeates the universe, where gravity sculpts ice and rock into timeless masterpieces. Past Saturn's shimmering rings lies Uranus, a world unlike any other, tilted dramatically on its side as if knocked askew in some ancient cosmic collision. Its pale blue-green hue, born from methane gas absorbing red light, lends it an ethereal glow in the darkness of space. Uranus's rotation axis is tilted by over 97 degrees, causing its poles to alternately face the sun and the darkness for decades, creating seasons unlike those on any other planet. This ice giant is a world of cold and mystery. Beneath its hazy atmosphere of hydrogen, helium, and methane lies a mantle of icy water, ammonia, and methane ices surrounding a rocky core. Uranus is less massive than Jupiter or Saturn, but still a giant compared to Earth, and its magnetic field, offset and tilted from its rotation axis, produces strange and shifting auroras that dance unpredictably across its skies. Uranus's moons, small and icy, revolve silently around their tilted master. Among them, Miranda stands out, a patchwork world of cliffs and canyons, scars of ancient geological upheaval that suggest violent internal processes despite the planet's frigid environment. These moons, though less celebrated than those of Jupiter or Saturn, hold clues to the nature of the ice giants and the formation of the solar system's outer reaches. Finally, as we journey farther into the cold darkness, we arrive at Neptune, the last of the classical planets, a distant world of deep blue mystery and fierce winds. Neptune's azure color, deeper and more vivid than Uranus, comes from methane in its atmosphere, but also from unknown constituents that absorb red light with greater intensity. It is a world of contrasts, a cold, distant giant where storms rage at supersonic speeds, and the atmosphere churns with massive clouds and dark spots, echoes of Jupiter's great red spot, but in shades of deep indigo. Neptune's winds are the fastest recorded in the solar system, reaching speeds over 2,000 kilometers per hour, whipping clouds into frenzies that circle the planet in mere hours. Its atmosphere layers reveal complex dynamics, where methane ice crystals form high clouds that drift above the turbulent storms below. Orbiting Neptune is a system of moons, the most famous being Triton, a world of frozen nitrogen and active geysers that erupt jets of nitrogen gas from its surface. Triton is unique among large moons, as it orbits Neptune in the opposite direction of the planet's rotation, a captured world from the distant Kuiper belt, pulled into the grasp of Neptune's gravity long ago. Its surface is a haunting landscape of ice plains, towering cliffs and mysterious dark streaks, shaped by processes we are only beginning to understand. Beyond Neptune lies the Kuiper belt, a vast ring of icy bodies and dwarf planets, including Pluto, once considered the ninth planet, now a symbol of the ever-evolving nature of our understanding. This distant frontier, shimmering on the edge of the solar system, holds countless relics from its formation, icy remnants that whisper secrets of the early sun and the building blocks of worlds. The solar system is more than a collection of planets orbiting a star. It is a living, breathing story, a cosmic tapestry woven of light and shadow, fire and ice, silence and storm. Each world, from the scorched surface of Mercury to the distant blue mysteries of Neptune, teaches us about the forces that shaped our home, the delicate balance required for life, and the infinite possibilities that lie beyond. As we stand on Earth, gazing upward, we are part of this grand dance, connected to each planet, each moon, each shining star, by the unseen threads of gravity and time. Mercury, Earth's closest neighbor to the sun, presents a world both harsh and captivating, forged in the furnace of solar proximity. Its surface is a rugged expanse of craters and cliffs, bearing the scars of countless impacts over billions of years. Without a substantial atmosphere to shield it, Mercury's landscape is exposed directly to the relentless solar wind and intense radiation. By day, temperatures soar to over 400 degrees Celsius, yet when night falls, the absence of atmospheric insulation causes temperatures to plummet below 170 degrees Celsius, painting a planet of extremes. The planet's thin exosphere, composed mainly of oxygen, sodium, and hydrogen, is so tenuous that it cannot retain heat or weather the surface. This fragile veil is constantly replenished by solar wind and micrometeoroid impacts, making Mercury a dynamic, albeit airless world. Its surface features vast, smooth plains interspersed with deep craters, including the colossal Caloris Basin, an impact scar over 1,500 kilometers wide, whose formation reshaped the planet's crust and created ripples across its surface like the rings of a cosmic pond. Mercury's internal structure is intriguing. A massive iron core, accounting for about 85% of the planet's radius, suggests a complex history of formation and contraction. The planet's magnetic field, though only about 1% as strong as Earth's, is a testament to a still active core, generating a magnetosphere that deflects solar particles and shapes its space environment. Orbiting the Sun in just 88 Earth days, Mercury races along a highly elliptical path, sometimes approaching closer to the Sun than at other times, making its motion a mesmerizing cosmic dance of speed and proximity. Its surface is a silent witness to the solar system's violent past, where ancient volcanoes shaped plains and tectonic forces folded the crust into towering scarps. Mercury challenges our understanding of planetary evolution, standing as a relic of early solar system processes and a laboratory for extremes, where temperature, gravity, and radiation converge in stark contrasts. Venus, often called Earth's twin for its similar size and mass, hides beneath thick clouds, a world vastly different from our own. Its dense atmosphere, composed mostly of carbon dioxide with clouds of sulfuric acid, traps heat in an intense greenhouse effect, driving surface temperatures to a staggering 465 degrees Celsius, hot enough to melt lead. This inferno transforms Venus into the hottest planet in the solar system, a place where pressure is over 90 times that of Earth's at sea level, crushing anything that dares to land upon its surface. The thick clouds obscure the surface from visible light, but radar mapping reveals a landscape of vast plains, volcanic mountains, and massive highland regions. Volcanoes, some potentially active, have shaped the planet's face, while immense lava flows have resurfaced large areas, erasing older features. Venus's slow rotation, taking 243 Earth days to complete a single spin and rotating backwards compared to most planets, adds to its mysterious character, creating atmospheric superrotation where winds race around the planet at hundreds of kilometers per hour. Venus's atmosphere is a turbulent sea of swirling storms and lightning, a dynamic and hostile environment where pressure, heat, and toxic gases create a world both alien and fascinating. Its history hints at a more temperate past, where oceans might have once existed before a runaway greenhouse transformed it into a fiery hellscape. Venus warns of the fragility of planetary climates and the powerful feedback loops that can tip a world into uninhabitable extremes. Mars, the red planet, with its rusty surface and thin atmosphere, continues to intrigue with its story of water and the quest for life. Evidence of ancient riverbeds, dried lakes, and polar ice caps suggests that Mars was once warmer and wetter, capable of supporting liquid water on its surface. Today, water exists mostly as ice locked in polar caps or as vapor in the atmosphere, while dust storms can envelop the entire planet for weeks, reshaping its surface and masking its mysteries. Mars's geography is dramatic. The vast canyon system of Valles Marineris stretches over 4,000 kilometers, dwarfing Earth's Grand Canyon, while the towering shield volcano Olympus Mons rises nearly 22 kilometers high, the tallest known volcano in the solar system. These features tell tales of a planet shaped by volcanic activity, tectonic stresses, and erosion, revealing a complex and dynamic history. The planet's weak magnetic field and thin atmosphere leave it vulnerable to solar radiation, challenging the survival of any potential life forms on its surface. The ongoing exploration of Mars, through robotic missions and orbiters, continues to reveal signs of ancient habitability, organic molecules, and seasonal methane variations that hint at underground processes. Mars stands as a symbol of exploration and the potential for human settlement beyond Earth, a world that beckons with both promise and peril. The gas giants, Jupiter and Saturn, dominate the outer solar system with their immense sizes and swirling atmospheres. Jupiter's majestic storms and powerful magnetosphere create a dynamic environment where energy flows on colossal scales. Its moons, diverse and numerous, form a miniature solar system with environments ranging from volcanic Io to icy Europa, each holding clues to planetary processes and the potential for life beyond Earth. Saturn's spectacular rings and moons reveal a system of delicate balances and interactions. Titan's thick atmosphere and hydrocarbon lakes offer a glimpse of prebiotic chemistry, while Enceladus's geysers erupt water and organic compounds into space, suggesting subsurface oceans that may harbor life. Saturn's beauty is a testament to the complexity and variety found in planetary systems. Uranus and Neptune, the ice giants, bring mystery and wonder with their tilted axes, methane-rich atmospheres, and extreme weather. Their moons, though less explored, present fascinating geologies and clues to the solar system's formation. Triton's retrograde orbit and active geology challenge our understanding of captured bodies and planetary evolution. The outer reaches of the solar system, including the Kuiper Belt and scattered disk, are home to dwarf planets and icy bodies that preserve the solar system's primordial materials. These distant worlds remind us of the vastness beyond the familiar, planets, and the continuing journey of discovery. In the grand architecture of the solar system, each planet is a chapter, each moon a verse in the cosmic poem. Together they tell a story of creation, transformation, and the delicate interplay of forces that govern the heavens. As we study these worlds, we deepen our connection to the universe and to the fragile blue dot we call home. The Sun, at the heart of the solar system, is a fiery sphere of plasma whose gravitational embrace holds the planets in their eternal dance. It is more than a luminous orb. It is the source of life and energy that drives the complex interplay of planetary climates, magnetic fields, and atmospheres. Its surface roils with turbulent convection. Sunspots darken its face like scars, and solar flares erupt with explosive power, sending charged particles streaming through space. The solar wind, a relentless stream of particles, sculpts the outer boundaries of the system, shaping planetary magnetospheres and creating stunning auroras on worlds like Earth and Jupiter. The Sun's life cycle is a reminder of the cosmic clock that governs all celestial bodies. Born from a collapsing cloud of gas and dust over 4.5 billion years ago, it will eventually expand into a red giant, engulfing the inner planets before shedding its outer layers and leaving behind a dense white dwarf. This future, distant yet inevitable, underscores the transient nature of even the mightiest stars and their systems. In this cosmic theater, the asteroid belt lies between Mars and Jupiter, a region filled with remnants of the early solar system. These rocky bodies, varying from dust-sized grains to dwarf planet-sized behemoths like Ceres, offer insight into the processes that shaped planetary formation. The belt is a chaotic zone where collisions and gravitational nudges keep asteroids on unstable paths, some venturing closer to Earth as near-Earth objects, reminding us of the fragile balance that governs planetary safety. Further out, the Kuiper Belt and the scattered disk stretch into the distant reaches beyond Neptune. These regions are populated with icy bodies, ancient relics from the solar nebula that have remained largely unchanged for billions of years. Pluto, once a planet and now a dwarf planet, resides here, along with other notable bodies like Eris, Haumea, and Makemake. These distant worlds harbor frozen nitrogen, methane, and water ices, their surfaces scarred by impacts and shaped by the faint sunlight that reaches them after hours of travel through space. The Oort cloud, a hypothesized spherical shell surrounding the solar system at the farthest edges, is thought to be a vast reservoir of comets. Though no direct observation has yet confirmed its existence, this cloud is believed to be the source of long-period comets that occasionally journey inward, their glowing tails lighting the night skies of Earth. These icy visitors bring with them clues to the early solar system's composition and the processes that governed planetary accretion and migration. The dynamic interplay between the Sun, planets, moons, and smaller bodies creates a system of staggering complexity and harmony. Gravity weaves invisible threads connecting each object, orchestrating their motions with precise rhythms. Magnetic fields, solar winds, and radiation sculpt atmospheres and surfaces, driving weather patterns and geological activity. Understanding. The solar system is a journey into the origins of our own existence. It reveals the forces that shaped the Earth, fostered life, and continue to influence our future. Each planet and moon, each asteroid and comet, is a chapter in this unfolding story, a testament to the raw power and delicate balance of nature on a cosmic scale. As our technology advances and our curiosity deepens, new missions venture to these distant worlds, probing their secrets and expanding our knowledge. From rovers on Mars to orbiters around the gas giants, from telescopes peering into the depths of space to sample return missions aiming to bring pieces of asteroids back to Earth, humanity reaches outward, driven by the timeless desire to understand the universe and our place within it. The solar system, with its myriad worlds and phenomena, invites us to dream, explore, and reflect. It challenges us to look beyond our daily lives, to contemplate the vastness and beauty of the cosmos, and to appreciate the delicate miracle of existence that unfolds on this pale blue dot amidst the stars. Mercury, the innermost planet, is a world of extremes and enigmas. Its proximity to the sun bathes it in intense radiation and heat, yet its lack of atmosphere allows temperatures to swing dramatically between scorching daylight highs and frigid nights. The surface is a tapestry of ancient craters and smooth plains, telling a story of violent bombardments and volcanic reshaping. The Caloris Basin stands as a monument to a colossal impact, its formation sending shockwaves across the planet's crust, creating ridges and troughs that ripple far beyond the impact zone. Beneath this scarred exterior lies a massive iron core, proportionally larger than that of any other terrestrial planet. This dense heart suggests Mercury underwent significant early heating and differentiation, with much of its original mantle stripped away by a giant impact or solar forces. This core still generates a weak magnetic field, offering a shield against the relentless solar wind, a subtle guardian in the solar furnace. Mercury's orbit is swift and elliptical, completing a circuit around the Sun in just 88 Earth days. Its rotational period is locked in a unique 3.2 resonance with its orbit, rotating 3 times for every 2 revolutions, creating a complex pattern of day and night that defies simple understanding. This intricate dance exposes some regions to prolonged sunlight while others experience extended darkness, contributing to the planet's severe temperature variations. Despite its small size and hostile conditions, Mercury holds keys to understanding the early solar system. Its preserved surface, magnetic field, and internal composition provide clues about planetary formation, core dynamics, and the effects. Solar proximity. As missions like Messenger and Bepi Colombo explore its mysteries, Mercury continues to reveal itself as a world both ancient and alive, with scientific intrigue. Venus, the second planet from the Sun, is shrouded in mystery. Beneath its dense reflective clouds, though similar in size and mass to Earth, Venus is a world transformed by a runaway greenhouse effect, where thick carbon dioxide blankets trap heat, creating surface temperatures hot enough to melt lead. This infernal environment is accompanied by crushing atmospheric pressure, nearly 100 times that of Earth, making the surface a realm of crushing force and fiery heat. Radar mapping has unveiled a landscape dominated by vast volcanic plains, towering mountains, and enormous highlands. Volcanism has played a significant role in shaping Venus, with evidence suggesting both ancient and possibly ongoing volcanic activity. The planet's slow, retrograde rotation, a single day longer than its year, adds to its enigmatic nature, influencing atmospheric dynamics and climate patterns in ways that still puzzle scientists. The sulfuric acid clouds that cloak Venus are both a shield and a source of danger, reflecting sunlight and hiding the planet's surface from direct view. Lightning flashes within these clouds hint at dynamic weather systems, while super-rotating winds whip around the planet at speeds far exceeding its rotation, distributing heat and energy with fierce intensity. Venus stands as a stark reminder of climate extremes and planetary evolution. Its past may have included oceans and temperate conditions, but feedback loops and atmospheric changes transformed it into a fiery world. Understanding Venus deepens our knowledge of atmospheric science and the delicate balance required for habitability. Mars, the 4th planet, beckons with its reddish hue and signs of a watery past. Its surface, scarred by ancient river valleys, dried lake beds, and polar ice caps, tells a story of a planet that once harbored flowing water and possibly life. Today, Mars is a cold desert, with a thin atmosphere unable to sustain liquid water. On the surface, yet seasonal methane emissions and underground ice hint at ongoing processes beneath the surface. The planet's geography is dramatic and varied. Valles Marineris, a canyon system stretching over 4,000 kilometers, dwarfs Earth's Grand Canyon and reveals tectonic forces in erosional history. Olympus Mons, a colossal shield volcano, towers nearly 22 kilometers high, the tallest known in the solar system, showcasing the planet's volcanic past. Mars's exploration has captivated humanity, with rovers uncovering soil chemistry, climate data, and signs of past habitability. The quest to understand Mars is also a quest to understand ourselves, our origins, our resilience, and our future as a species that may one day call another world home. The gas giants Jupiter and Saturn reign in the outer solar system with their massive sizes and complex systems. Jupiter's swirling bands of clouds and the iconic Great Red Spot, a storm larger than Earth, reveal turbulent atmospheres driven by rapid rotation and internal heat. Its powerful magnetic field, the strongest among the planets, shapes an extensive magnetosphere filled with energetic particles. Jupiter's moons form a miniature solar system of their own. Io, the most volcanically active body in the solar system, continually reshapes its surface through intense tidal heating. Europa's icy crust conceals a global subsurface ocean, making it a prime candidate for extraterrestrial life. Ganymede, the largest moon, boasts its own magnetic field, while Callisto's ancient surface preserves a record of early solar system impacts. Saturn's beauty is legendary, its majestic rings composed of countless icy particles reflecting sunlight with dazzling brilliance. The rings are dynamic, with waves, gaps, and moonlets interacting in a celestial ballet. Saturn's moons, diverse and intriguing, range from Titan, with a thick nitrogen atmosphere and hydrocarbon lakes, to Enceladus, whose geysers spew water, and organic molecules hinting at a subsurface ocean that may harbor life. The ice giants Uranus and Neptune are distant, mysterious worlds with unique characteristics. Uranus rotates on its side, with an axial tilt of nearly 98 degrees, creating extreme seasonal variations. Its atmosphere, rich in methane, gives it a pale blue color, while faint rings and numerous moons complete its system. Neptune, darker and more intense, boasts the fastest winds in the solar system and great storms, including the now faded Great Dark Spot. Neptune's moon Triton is a world of intrigue, with geysers of nitrogen and a retrograde orbit suggesting it was captured from the Kuiper Belt. These ice giants challenge our understanding of planetary formation and migration, highlighting the diversity of worlds beyond the familiar terrestrial and gas giants. The solar system extends far beyond these planets. The Kuiper Belt, home to dwarf planets like Pluto, Eris, and Haumea, is a frozen frontier of icy bodies that preserve the solar system's earliest materials. These objects, remnants of the primordial disk from which planets formed, offer insight into the processes that shaped our cosmic neighborhood. Beyond lies the hypothesized Oort cloud, a vast spherical shell of icy bodies that may send comets hurtling into the inner solar system. Though yet to be observed directly, this distant region marks the boundary of the sun's gravitational influence and the threshold between our solar system and interstellar space. Together, the planets, moons, asteroids, and comets form a complex and dynamic system, bound by gravity and energized by the sun's light and heat. Their stories, etched in rock and ice, atmosphere, and magnetic field, weave a cosmic tapestry of formation, change, and possibility. As we continue to explore and learn, the solar system reveals not only the nature of distant worlds, but the origins of our own planet and the place of life in the universe. The delicate balance within the solar system is a product of forces both immense and subtle, an interplay of gravity, momentum, and energy that has persisted for billions of years. Each planet follows its path around the sun, tracing elliptical orbits governed by Kepler's laws. Yet these orbits are not static. They are influenced by the gravitational tugs of neighboring planets, the occasional passing comet, and the remnants of ancient collisions, creating a dynamic celestial choreography. Mercury's orbit, closest to the sun, is not a perfect ellipse, but slightly shifts over time, a phenomenon known as perihelion precession. This subtle motion was a key test of Einstein's theory of general relativity, confirming that gravity is not merely a force, but the curvature of space-time itself. This discovery illustrates how the study of our solar system connects the very large and the very small, from planets to fundamental physics. Venus's thick atmosphere and slow retrograde rotation create a climate unlike any other. The greenhouse effect here is extreme. trapping heat and driving atmospheric winds at hundreds of kilometers per hour in the upper layers. This thick veil of clouds reflects much of the sunlight, making Venus one of the brightest objects in Earth's night sky, visible to the naked eye. Yet beneath these clouds, the surface is harsh and enigmatic, sculpted by volcanism and shaped by tectonic forces that are still poorly understood. Earth, our home, is unique in the solar system. Its abundant liquid water, protective magnetic field, and oxygen-rich atmosphere support an incredible diversity of life. The planet's position in the habitable zone allows temperatures suitable for life as we know it. Earth's geological activity, from plate tectonics to volcanism, continuously reshapes its surface and recycles its atmosphere and oceans. The presence of a large, stabilizing moon influences tides and stabilizes Earth's axial tilt, contributing to climatic stability over geological timescales. Mars, once warmer and wetter, reveals the fragility of habitability. Its thin atmosphere cannot retain heat or shield the surface from harmful radiation, yet the signs of ancient riverbeds, mineral deposits formed in water, and the presence of frozen ice caps remind us that conditions suitable for life may have existed in the past. The exploration of Mars not only seeks to understand its history, but also the potential for future human settlement. Jupiter's immense gravity influences the entire solar system, shaping asteroid orbits and protecting the inner planets from frequent comet impacts. Its magnetic field traps charged particles, creating intense radiation belts that would be lethal to unprotected spacecraft or life forms. Jupiter's turbulent atmosphere is a canvas of belts and zones, storms and eddies, a planet alive with movement and energy. Saturn's rings are a masterpiece of cosmic art and physics, made mostly of ice particles ranging from tiny grains to house-sized chunks. The rings are structured by gravitational interactions with Saturn's moons, which carve gaps and shepherd the particles into complex patterns. These rings are thought to be relatively young, possibly the remnants of a shattered moon or comet, offering a glimpse into processes that may have occurred elsewhere in the solar system. Uranus and Neptune, the ice giants, are colder, denser, and more mysterious. Uranus's extreme tilt means that its poles experience decades of sunlight, followed by decades of darkness, creating climate phenomena not seen on other planets. Its faint rings and numerous moons form a system of their own, shaped by past collisions and gravitational interactions. Neptune's deep blue color comes from methane absorption of red light, while its atmosphere is marked by dynamic storms and high-speed winds despite its great distance from the sun. The moons of these outer planets add depth and diversity to the solar system's story. Titan, Saturn's largest moon, possesses a dense atmosphere rich in nitrogen and methane, with rivers and lakes of liquid hydrocarbons sculpting its surface. Enceladus, also orbiting Saturn, jets water vapor and organic molecules from fissures near its south pole, suggesting a subsurface ocean that could harbor microbial life. Jupiter's Europa captivates scientists with its smooth, icy surface, beneath which lies a salty ocean kept warm by tidal forces. This ocean is a prime target in the search for extraterrestrial life, where hydrothermal vents may exist, providing energy and nutrients for organisms. The solar system is not static, but a place of change and transformation. Comets, icy visitors, from the distant reaches, blaze through the inner solar system, shedding gas and dust as their ices vaporize under the sun's heat. Asteroids collide and fragment, sometimes sending debris toward Earth. Meteoroids enter our atmosphere, creating fleeting streaks of light and delivering material from space to Earth's surface. Spacecraft launched by humanity have ventured to every planet, revealing wonders and surprises. From the Mariner missions to the Voyagers that have now entered interstellar space, to rovers and landers exploring Martian terrain, these emissaries expand our knowledge and inspire our imaginations. The story of the solar system is a story of origins, evolution, and the profound interconnections of all matter and energy. It is a testament to the grandeur of the cosmos and the remarkable chance that brought life to Earth, a fragile blue oasis amid the vastness of space. The journey through the solar system reveals a vast spectrum of planetary diversity, each world shaped by its unique environment and history. Mercury's scorched terrain and large iron core contrast sharply with Venus's suffocating atmosphere and volcanic plains, while Earth's vibrant biosphere stands apart as a singular oasis. Mars's barren deserts and ancient river valleys whisper of a climate long past, evoking questions about life's persistence beyond our planet. The gas giants, Jupiter and Saturn, dominate the outer reaches with their immense size and complex systems. Jupiter's turbulent storms and powerful magnetosphere reveal a planet of energy and motion, while Saturn's iconic rings shimmer like cosmic jewels, products of gravity's delicate balance and time's passage. The ice giants, Uranus and Neptune, are distant, cold, and enigmatic, their atmospheric mysteries and tilted orbits inspiring scientific curiosity and speculation. Each planet's formation traces back to the swirling protoplanetary disk that once surrounded the young. Sun dust and gas coalesced under gravity, forming planetesimals that collided and merged into the worlds we see today. This process was chaotic and violent, punctuated by massive impacts that reshaped planets and cleared debris. The solar system's architecture, inner rocky planets, outer gas and ice giants, and distant belts of minor bodies, reflects the temperature, gradient, and dynamics of the early disk. The asteroid belt, lying between Mars and Jupiter, contains remnants of this formation era. These rocky bodies failed to form a planet, their growth halted by Jupiter's strong gravity stirring the region. The belt includes Ceres, the largest asteroid and a dwarf planet, whose surface shows signs of water ice and possible cryovolcanism, bridging the gap between rocky worlds and icy bodies. Beyond lies the Kuiper Belt, a reservoir of icy objects, and dwarf planets like Pluto, whose reclassification sparked debates about planetary definitions. These distant bodies hold clues to the solar system's primordial composition, preserved in the cold and darkness of space. The discovery of objects beyond Pluto, such as Eris and Makemake, expanded our understanding of the solar system's size and diversity. Comets, originating from both the Kuiper Belt and the hypothesized Oort cloud, are messengers from the outer reaches. Their spectacular tails develop as ices sublimate when nearing the sun, releasing gas and dust. Studying comets informs us about the early solar system's chemistry and the delivery of water and organic materials to Earth, potentially crucial for life's emergence. The interplay of gravitational forces governs the orbits and interactions of all these bodies. Resonances between planets and smaller objects can create gaps, clusters, and complex orbital patterns. The study of orbital dynamics reveals how planets migrate, how moons are captured, and how the solar system maintains its relative stability despite ongoing perturbations. Solar radiation, solar wind, and cosmic rays interact with planetary atmospheres and magnetic fields, shaping weather, climate, and space environments. Earth's magnetosphere deflects harmful solar particles, protecting life, while other planets experience harsh radiation environments. Auroras dance in polar skies of Earth, Jupiter, and Saturn, a beautiful consequence of charged particles colliding with atmospheric gases. The Sun itself is the heart of the system, a massive nuclear furnace generating light and heat that sustain planetary climates. Its life cycle, from main sequence to eventual red giant, will dictate the solar system's future, altering or destroying planets and leaving behind a white dwarf remnant. This cosmic evolution connects us to the stars, reminding us that planets and life are transient in a vast and dynamic universe. As humanity looks outward, the solar system becomes both a laboratory and a stepping stone for exploration beyond. The quest to understand planetary environments, potential habitats, and resources fuels missions and dreams of interplanetary travel. The story of the solar system is a story of discovery, wonder, and the enduring human spirit reaching for the stars. The planets of our solar system stand as monuments to the forces of nature that shaped them: gravity, rotation, magnetic fields, and atmospheric chemistry, all interacting over billions of years to create worlds both alien and familiar. There, stories are written in the rocks and clouds, the ice and dust, the storms that rage across vast atmospheres and the silent orbits they trace around our sun. Mercury, the smallest and fastest planet, bears the scars of a violent history. Its heavily cratered surface tells of ancient impacts, while its iron-rich core and thin mantle reflect processes that have stripped away lighter materials. The extreme temperature swings between day and night speak to the lack of atmosphere and the proximity to the sun's relentless heat. Despite these harsh conditions, Mercury's magnetic field hints at an active interior, a dynamo still pulsing beneath the surface. Venus, often called Earth's twin due to its similar size and composition, is a planet of extremes. Its dense, toxic atmosphere traps heat in a runaway greenhouse effect, turning the surface into a furnace hotter than Mercury's. The sulfuric acid clouds swirl in super-rotating winds, encircling the planet every 4 Earth days. Volcanoes dot the landscape, some possibly still active, shaping a world where the past and present volcanism has sculpted a young surface amid a seemingly hostile environment. Earth's vibrant biosphere and dynamic geology make it unique in our known cosmos. Plate tectonics recycle the crust, drive the carbon cycle, and create diverse landscapes. The atmosphere and oceans maintain climate balance and support life, while the magnetic field shields the surface from harmful solar and cosmic radiation. Earth's moon stabilizes its axial tilt, helping preserve the rhythms of seasons and climate, nurturing life's evolution over millions of years. Mars evokes a tale of transformation, a world once warmer and wetter now reduced to a cold desert. Evidence of ancient river valleys, lake beds, and minerals formed in water suggests Mars once had a thick atmosphere and possibly conditions suitable for life. The loss of this atmosphere to space, driven by solar wind and the planet's weak magnetic field, transformed Mars into the arid world we see today. Its towering volcanoes and vast canyons hint at a geologically active past, while polar ice caps composed of water and dry ice shift with the seasons. Jupiter's majestic presence dominates the outer solar system. Its composition of hydrogen and helium mirrors the Sun's, a gas giant whose immense gravity influences countless bodies. The Great Red Spot, a massive storm persisting for centuries, is a symbol of the planet's turbulent atmosphere. Jupiter's magnetic field is the strongest among the planets, generating radiation belts that envelop its moons. Its diverse system of moons ranges from volcanic Io, heated by tidal forces, to icy Europa, with a subsurface ocean that may harbor life. Saturn, renowned for its spectacular rings, offers a glimpse into cosmic processes on both grand and minute scales. The rings themselves are composed of countless ice and rock particles, constantly shaped by gravitational interactions and collisions. Saturn's many moons, from the methane-rich Titan to the geysering Enceladus, showcase worlds with complex atmospheres, internal oceans, and geological activity, providing intriguing targets for astrobiology. Uranus challenges our expectations with its tilted axis, rolling on its side as it orbits the Sun. This unique orientation leads to extreme seasonal variations, with each pole experiencing 42 years of continuous sunlight or darkness. Uranus's atmosphere is primarily hydrogen and helium, with methane giving it a blue-green hue. Its faint rings and moons form a system that reflects the planet's complex history, shaped by collisions and gravitational forces. Neptune, the farthest known planet, reveals a dynamic and energetic world despite its distance from the Sun. Its deep blue color is caused by methane absorption, and its atmosphere hosts the fastest winds in the solar system. Neptune's moon, Triton, is geologically active, with nitrogen geysers suggesting internal heat. The planet's gravitational influence extends far into the Kuiper belt, sculpting the orbits of distant objects and hinting at the vastness of the solar system's gravitational domain. Together, these planets form a family of worlds, each with its own character and mysteries. They illustrate the processes of planetary formation and evolution, and they challenge us to understand the delicate balance that sustains environments where life might arise. As we continue to explore and study these distant neighbors, we deepen our connection to the cosmos and our appreciation for the fragile place we call home. The solar system's moons add richness and complexity to this celestial family, each one a unique world with its own story. From the countless tiny satellites orbiting the gas giants to the larger moons with atmospheres and oceans, these bodies expand our understanding of planetary science and astrobiology. They remind us that the universe is not static, but alive, with dynamic processes, even in seemingly inhospitable places. Earth's moon, our closest celestial companion, has long inspired humanity's imagination and exploration. Its cratered surface is a record of the solar system's early days, preserved due to the absence of atmosphere and weather. The moon influences Earth's tides, stabilizes its axial tilt, and acts as a stepping stone for humanity's venture into space. The Apollo missions revealed a dry, rocky world, but recent discoveries of water ice in shadowed craters hint at resources for future explorers. Mars's two small moons, Phobos and Deimos, are irregularly shaped and heavily cratered, thought to be captured asteroids. Their origins and future remain subjects of study, with Phobos gradually spiraling inward and expected to either crash into Mars or break apart, potentially forming a temporary ring in the distant future. Jupiter's extensive moon system includes the volcanic Io, where intense tidal heating creates constant eruptions, reshaping the surface in vivid colors. Europa, with its smooth icy crust and evidence of a subsurface ocean, is a prime target for missions searching for extraterrestrial life. Ganymede, the largest moon in the solar system, is larger than Mercury and possesses its own magnetic field, a remarkable feature for a moon. Callisto's heavily cratered surface speaks to an ancient and stable history, possibly harboring an ocean beneath its ice. Saturn's moons are equally fascinating. Titan's dense atmosphere and hydrocarbon lakes create an Earth-like environment in many ways, with methane rain and seasonal cycles. Enceladus emits plumes of water vapor and ice particles from its south polar region, evidence of a subsurface ocean warmed by tidal forces. These plumes contain organic molecules, making Enceladus one of the most promising places to search for life beyond Earth. Uranus's moons, such as Miranda with its strange coronae, or Ariel with its signs of geological activity, tell stories of past heating and internal evolution. Neptune's largest moon, Triton, is a captured Kuiper Belt object, orbiting backward and displaying active geysers that eject nitrogen gas. These moons broaden the horizons of planetary science, showing that even distant cold worlds can be dynamic and intriguing. The solar system also contains dwarf planets, small worlds that blur the line between planet and minor body. Pluto, once considered the ninth planet, is now classified among these intriguing objects. Its complex geology, atmosphere, and moons challenge previous assumptions about the outer solar system. Objects like Eris, Haumea, and Makemake add to this category, highlighting the diversity of bodies beyond the main planets. The asteroid belt between Mars and Jupiter is a region filled with rocky remnants, from tiny dust grains to Ceres, the largest asteroid, and a dwarf planet. These objects provide insight into the solar system's formation and the processes that prevented them from coalescing into a larger planet. Collisions among asteroids generate meteorites that occasionally reach Earth, offering samples from distant times and places. The Kuiper Belt and Oort cloud represent the farthest reaches of the solar system's influence. The Kuiper Belt, home to many icy bodies and dwarf planets, extends beyond Neptune's orbit and is a source of short-period comets. The distant Oort cloud is a hypothesized spherical shell of icy objects that may extend nearly a light-year from the Sun, serving as a reservoir for long-period comets. These regions connect the solar system to the galaxy, acting as boundaries between our Sun's influence and the interstellar medium. Our understanding of the solar system continues to grow through exploration and observation. Space missions, like Voyager, Cassini, New Horizons, and Juno, have transformed distant points of light into rich worlds, revealing surprises and raising new questions. Telescopes, both on Earth and in space, observe planetary atmospheres, rings, and surfaces, while laboratory experiments and computer models help decode the complex processes shaping these worlds. As we learn more, we see the solar system not as isolated, but as part of a vast cosmos filled with billions of stars and countless planetary systems. The questions we ask about the origin, evolution, and habitability of planets guide us toward understanding our place in the universe and the potential for life beyond Earth. The solar system is a testament to nature's creativity and complexity, a grand cosmic neighborhood where each world tells a story. By studying these planets and their moons, we not only satisfy our curiosity, but also deepen our appreciation for the delicate balance that allows life to flourish on our own pale blue dot. The formation of the solar system began over 4.6 billion years ago in a vast molecular cloud, a stellar nursery rich with gas and dust. This cloud, disturbed by a nearby supernova or other energetic event, began to collapse under its own gravity. As it contracted, conservation of angular momentum caused it to spin faster, flattening into a rotating protoplanetary disk surrounding a dense central protostar, the young sun. Within this disk, tiny particles of dust collided and stuck together, gradually building up into larger clumps known as planetesimals. These planetesimals, ranging from meters to kilometers in size, collided repeatedly, merging and accreting material to form protoplanets. The inner solar system, hotter and more energetic, saw the formation of rocky planets like Mercury, Venus, Earth, and Mars. Here, volatile elements evaporated away, leaving dense, metal-rich worlds with silicate mantles and thin atmospheres. In contrast, the cooler outer solar system allowed ices to remain solid, facilitating the formation of the gas and ice giants, Jupiter, Saturn, Uranus, and Neptune, massive planets with thick gaseous envelopes dominated by hydrogen, helium, methane, and ammonia. Jupiter's rapid growth played a crucial role in shaping the solar system's architecture. Its immense gravity shepherded material in the outer disk, stirring up planetesimals and preventing a planet from forming between Mars and Jupiter. This dynamic region became the asteroid belt, populated with remnants of primordial material. Jupiter's gravity also influenced the orbits of outer bodies, sculpting the Kuiper belt and contributing to the scattering of icy objects into the distant Oort cloud. The formation process was violent and chaotic. Large impacts shaped planetary surfaces and even entire planetary bodies. Earth's moon, for instance, likely formed from the debris of a colossal impact between the proto-Earth and a Mars-sized object named Theia. This giant collision ejected material that coalesced into the moon, stabilizing Earth's rotation and influencing its climate. Throughout this era, the young sun emitted intense solar winds and radiation, gradually blowing away the residual gas and dust from the protoplanetary disk. This clearing allowed the planets to emerge as distinct bodies, with stable orbits, setting the stage for billions of years of evolution. The composition and structure of each planet reflect this formative history. Mercury's dense iron core and thin mantle may result from intense solar heating stripping away lighter materials. Venus's thick atmosphere and volcanic surface hint at a runaway greenhouse effect and ongoing geological activity. Earth's water-rich environment is unique in the inner solar system, influenced by late delivery of volatile-rich comets and asteroids. Mars's arid deserts and polar ice caps tell a story of atmospheric loss and climate change. The gas giants' layered interiors are a subject of ongoing research, with hydrogen and helium transitioning into exotic metallic states under extreme pressures. Their magnetic fields and complex atmospheres arise from internal dynamics and rapid rotation. The ice giants' compositions include larger proportions of ices, water, methane, ammonia, shaping their blue-green hues and weather patterns. Understanding planetary formation helps astronomers interpret the diverse exoplanetary systems discovered beyond our own. It reveals how common processes can yield widely different planetary outcomes, depending on factors like stellar type, disk mass, and planetary migration. The solar system's formation is not merely a story of rocks and gas, but a prelude to the emergence of life on Earth. shaped by the delivery of water and organic molecules, the stability of our orbit, and the protection from cosmic hazards. It is a cosmic dance that set the stage for complexity and consciousness to arise in the vast universe. The mysteries of the solar system extend far beyond the planets themselves, into the dynamic interactions that govern their movements and relationships. Orbital mechanics, the science of how celestial bodies move under gravity's influence, dictates the rhythm of planetary revolutions, rotations, and gravitational pulls, creating a cosmic choreography that has persisted for billions of years. Each planet's orbit around the Sun is an ellipse, with varying eccentricities that shape the distance and speed at different points. Mercury's orbit is the most eccentric, swinging closer and farther from the Sun, contributing to its extreme temperature fluctuations. Earth's nearly circular orbit maintains a relatively stable climate, aiding the development of life. The outer planets, while farther apart, follow elliptical paths that sometimes bring them closer together in rare alignments. The tilt of a planet's axis, its obliquity, affects seasons and climate. Earth's 23.5-degree tilt produces the familiar cycle of seasons, while Uranus's extreme 98-degree tilt causes its poles to face the Sun directly during long summers and to plunge into darkness during winters. Mars's axial tilt is similar to Earth's, but with greater variations over time, contributing to its climate shifts and polar ice cap changes. Planetary rotation rates also vary widely. Mercury rotates slowly, completing one rotation every 59 Earth days, while Jupiter spins rapidly, with a day lasting just under 10 hours. This rapid rotation creates strong Coriolis forces, driving intense storms and banded cloud patterns on Jupiter and Saturn. Venus's retrograde rotation, spinning opposite its orbit, remains a subject of study, possibly caused by past collisions or tidal interactions. Gravitational interactions between planets and moons generate tides, orbital resonances, and even migration. Earth's moon raises tides in our oceans, stabilizes Earth's rotation, and gradually moves away over time. Io's volcanic activity is powered by tidal heating from its interaction with Jupiter and neighboring moons Europa and Ganymede, creating a gravitational tug-of-war that flexes its interior. Orbital resonances occur when two or more bodies exert regular gravitational influence on each other, locking their orbital periods into integer ratios. Pluto and Neptune are in a 3.2 resonance, ensuring they never collide despite crossing orbits. Similar resonances maintain gaps in Saturn's rings, shaped by moons shepherding ring particles. The solar system's stability is remarkable, given the complex gravitational forces at play. Over millions of years, perturbations and chaotic effects can alter orbits, but overall, the system has persisted in a delicate balance. This stability has allowed life to evolve on Earth without catastrophic disruptions. Occasionally, small bodies such as asteroids and comets cross planetary paths, posing impact risks. Large impacts have shaped Earth's history, causing mass extinctions and climatic upheavals. The study of near-Earth objects is vital for planetary defense and understanding the solar system's ongoing evolution. Beyond planetary orbits, the solar system is embedded in the Milky Way galaxy, orbiting its center every 250 million years. Galactic tides and passing stars can influence distant objects in the Oort cloud, sending comets into the inner solar system and connecting our system to the broader cosmic environment. This intricate web of gravitational relationships forms a dynamic, evolving system, a celestial symphony where each planet, moon, and minor body plays a role in the unfolding story of our solar neighborhood. The atmospheres enveloping the planets are gateways to understanding their climates, compositions, and potential for supporting life. Though thin or thick, simple or complex, these gaseous envelopes tell tales of chemical reactions, solar influence, and geological activity, shaping each world's identity in profound ways. Mercury's atmosphere is negligible, a tenuous exosphere formed mostly from solar wind particles and atoms ejected from its surface by micrometeorite impacts and solar radiation. Its lack of a substantial atmosphere means temperatures swing dramatically between day and night, creating a harsh environment largely unshielded from cosmic radiation. Venus, cloaked in dense clouds of sulfuric acid and carbon dioxide, possesses a runaway greenhouse atmosphere, hotter than Mercury's surface despite being farther from the Sun. This thick atmosphere traps heat efficiently, producing surface temperatures around 465 degrees Celsius. High pressure and corrosive clouds make Venus an extreme world, with winds swirling at hurricane speeds high above the surface and surface conditions resembling a blazing furnace. Earth's atmosphere is a delicate balance of nitrogen, oxygen, and trace gases, creating a protective shield that supports life. Its layered structure, troposphere, stratosphere, mesosphere, thermosphere, and exosphere, regulates weather, filters harmful radiation, and maintains temperature ranges suitable for life. Water vapor cycles through evaporation and precipitation, driving weather systems and sustaining ecosystems. The presence of oxygen is largely due to photosynthetic life, illustrating the profound connection between atmosphere and biology. Mars's thin atmosphere is composed mainly of carbon dioxide, with pressures less than 1% of Earth's. Seasonal changes cause carbon dioxide to freeze and sublimate at the poles, creating visible changes in polar caps. Dust storms, sometimes planet-wide, sweep across its surface, altering the landscape and challenging robotic explorers. Evidence suggests Mars once had a thicker atmosphere and liquid water, raising questions about its past habitability. Jupiter's atmosphere is a turbulent canvas of hydrogen, helium, and trace gases, marked by colorful bands and the famous Great Red Spot, a massive storm persisting for centuries. Layers of clouds made of ammonia, ammonium hydrosulfide, and water crystals form complex weather systems, with lightning and powerful winds driven by internal heat escaping from the planet's core. Saturn's atmosphere, similar in composition to Jupiter's, features extensive ring shadows, storms, and hexagonal jet streams at its poles. The planet's low density causes its atmosphere to extend far from the core, with layered cloud decks that change with seasons. Cassini's observations revealed transient storms and complex auroras, powered by interactions with the solar wind. Uranus and Neptune, the ice giants, harbor atmospheres rich in methane, giving their distinctive blue-green colors. Uranus's atmosphere is generally calm with faint cloud features, while Neptune's is dynamic with the fastest winds observed in the solar system, reaching supersonic speeds. Both show seasonal and long-term variations influenced by their axial tilts and distances from the Sun. The study of planetary atmospheres informs our understanding of climate change, atmospheric loss, and the delicate balance required to sustain life. The detection of atmospheres on exoplanets and the search for biosignatures is a frontier in astronomy, inspired by the diverse atmospheric phenomena within our own solar system. Atmospheres act as both shields and storytellers, preserving records of planetary history, surface interactions, and solar influences. They frame the worlds they surround, shaping conditions from scorching hellscapes to life-supporting havens, reflecting the endless variety and complexity of planetary environments. The moons of the solar system form a constellation of miniature worlds, each with its own character, history, and mysteries. Orbiting planets from Mercury to Neptune, these natural satellites range from barren rocky spheres to active ocean worlds, and in some cases, they rival or even surpass planets in geological and scientific interest. Mercury and Venus are devoid of moons. Their proximity to the Sun and lack of substantial gravitational influence leaving them isolated in space. But from Earth outward, moons begin to populate the planetary realms like celestial companions with unique voices. Earth's moon is the most familiar, its craters, highlands, and Maria visible to the naked eye. Born of a cataclysmic collision, early in Earth's history, the moon has shaped tides, stabilized Earth's axial tilt, and recorded a history of solar system impacts on its ancient surface. Its far side, hidden from Earth's view, remained unknown until spacecraft revealed its rugged terrain. Despite its silence, the moon has long inspired mythology, poetry, and science, and continues to play a pivotal role in our future space. Exploration plans. Mars hosts two irregular moons, Phobos and Deimos, thought to be captured asteroids or remnants of a larger moon shattered by collisions. Phobos orbits dangerously close, inching toward Mars and destined to break apart or crash into the planet within millions of years. These moons may be small, but they are enigmatic, their origins uncertain and their surfaces scarred by impacts and grooves. Beyond Mars, the gas and ice giants become moons' cradles. Jupiter, with over 90 known moons, reigns as the monarch of moon systems. Among them, the Galilean moons, Io, Europa, Ganymede, and Callisto, stand out as titanic and varied worlds. Io is a volcanic inferno, its surface constantly reshaped by sulfurous eruptions. Europa, beneath its icy crust, harbors a subsurface ocean that may conceal alien life in its dark, salty depths. Ganymede, the largest moon in the solar system, has its own magnetic field and shows signs of internal oceans and past tectonic activity. Callisto, ancient and cratered, remains geologically quiet but holds a beauty in its static, frozen form. Saturn's moons paint a similarly fascinating picture. Titan, the second largest moon in the solar system, boasts a thick, nitrogen-rich atmosphere and lakes of liquid methane and ethane, creating a hydrocarbon weather cycle akin to Earth's water system. Beneath its icy shell lies a vast ocean, offering another possible niche for life. Enceladus, though much smaller, astonishes scientists with plumes of water vapor and ice erupting from its south pole, feeding Saturn's E-ring and suggesting a warm, salty ocean below. Its geysers contain organic compounds, tantalizing hints of chemistry that could support life. Uranus's moons are shadowy and mysterious, orbiting a planet tipped on its side. Miranda's jumbled surface appears as if torn apart and reassembled, while Ariel and Umbriel show signs of resurfacing and cratering. Neptune's largest moon, Triton, is unique among large moons for its retrograde orbit, suggesting it was captured from the Kuiper Belt. Triton is geologically active, with cryovolcanoes and nitrogen geysers, its surface a frigid yet dynamic landscape marked by cantaloupe terrains and icy plains. Moons are more than passive companions. They influence planetary rings, raise tides, trigger volcanic and tectonic activity, and preserve records of solar system formation. Some are thought to have formed from the same disks as their host planets. Others were captured during the chaotic, early solar system, or born from impacts. The diversity among moons points to the creative and violent processes that shape the solar system. From the volcanic fury of Io to the silent oceans of Europa and the hazy skies of Titan, they stand as sentinels of cosmic history, each one a frozen whisper or a rumbling voice from the depths of time. The asteroid belt, nestled between Mars and Jupiter, is a vast and varied region filled with remnants from the early solar system. These rocky bodies, ranging in size from tiny pebbles to dwarf planets hundreds of kilometers wide, offer a glimpse into the primordial materials and processes that shape the planets. Unlike planets, asteroids failed to coalesce into a larger body, their growth stunted by Jupiter's powerful gravitational influence, which stirred the belt and prevented accretion. Within this cosmic rubble field, the largest object is the dwarf planet Ceres, a world of ice and rock with a tenuous atmosphere and intriguing geological activity. Ceres's surface reveals bright spots, salt deposits left by mysterious subsurface brine reservoirs, hinting at a hidden ocean beneath its crust. This ocean, if confirmed, makes Ceres a compelling candidate for astrobiological studies, bridging the gap between rocky asteroids and icy moons. Asteroids come in different compositions: carbon-rich C-type, silicate S-type, and metallic M-type, each carrying unique information about the solar system's chemistry and thermal history. C-types are dark and primitive, resembling the building blocks of life's essential compounds, while S-types are brighter and more evolved, Metallic M-types may be fragments of larger bodies that once differentiated, their metallic cores exposed by ancient collisions. Asteroids play a vital role beyond scientific curiosity. Occasionally, they cross Earth's orbit, becoming near-Earth objects, NEOs, that pose potential impact threats. Understanding their orbits, sizes, and compositions is crucial for planetary defense efforts. NASA and other space agencies have launched missions to study asteroids directly, including sample return missions like OSIRIS-REx to Bennu and Hayabusa-2 to Ryugu, bringing back precious materials to Earth for detailed analysis. The asteroid belt also acts as a natural laboratory for studying collision dynamics, surface weathering, and space environment effects. The lack of atmosphere on these bodies means surfaces are shaped by micrometeorite bombardment and solar radiation, preserving ancient records inaccessible on Earth. Beyond the asteroid belt lies the realm of comets, icy wanderers from the outer solar system that carry pristine materials from the coldest, most distant reaches. Comets are composed of frozen gases, dust, and rocky material, dirty snowballs that develop glowing comas and tails when heated by the sun's rays. Their highly elliptical orbits bring them close to the sun, where sublimation of ices creates spectacular displays visible even to the naked eye. Comets originate primarily from two reservoirs, the Kuiper Belt and the Oort cloud. The Kuiper Belt, a disk of icy objects beyond Neptune, contains dwarf planets like Pluto and a host of smaller bodies. The Oort cloud is a vast, spherical shell surrounding the solar system at great distances, home to trillions of icy bodies disturbed occasionally by passing stars or galactic tides, sending comets inward. Studying asteroids and comets informs us about the delivery of water and organic materials to Earth, possibly seeding life itself. Their ancient, unaltered nature preserves clues about the solar system's formation and the early sun's activity, anchoring our understanding of planetary origins. These small bodies, often overlooked in favor of planets and moons, are fundamental actors in the solar system story. Their presence, composition, and behavior deepen our appreciation of the complex, interconnected system that surrounds us, reminding us that even the smallest fragments hold cosmic significance. The Kuiper Belt lies beyond Neptune's orbit, a distant region populated by icy bodies and dwarf planets, marking the boundary between the familiar planetary neighborhood and the vast, dark depths of the outer solar system. It represents a repository of ancient remnants, preserved in the cold and quiet, offering a window into the conditions prevailing in the solar system's infancy. Unlike the asteroid belt's rocky fragments, Kuiper Belt objects, KBOs, are composed primarily of frozen volatiles, water, methane, ammonia, and nitrogen ices, mixed with rock and organic compounds. This composition gives them a distinctive gleaming appearance in the cold, distant sunlight, their surfaces altered by cosmic rays and the slow dance of sublimation over billions of years. Pluto, once considered the ninth planet, is the Kuiper Belt's most famous resident and its largest known object. Pluto's surface is a tapestry of nitrogen ice plains, mountains of water ice, and hazy, nitrogen-rich atmosphere. Its orbital eccentricity and inclination differ sharply from those of the classical planets, a clue to the dynamical processes that sculpted this outer region. The New Horizons mission revealed a surprisingly complex and geologically active world, with vast glaciers, cryovolcanoes, and a heart-shaped basin known as Tomball Regio, captivating scientists and the public alike. Beyond Pluto, a host of other dwarf planets and KBOs await study, including Eris, Haumea, and Makemake. Eris, slightly smaller than Pluto but more massive, challenged the traditional definition of a planet and helped establish the new category of dwarf planets. Haumea's rapid rotation and elongated shape, along with its collisional family of fragments, suggest a violent past. Makemake's bright surface and lack of atmosphere add to the diversity of these distant bodies. The Kuiper Belt is not merely a static collection of icy relics. Its objects undergo slow resurfacing, seasonal changes, and occasional collisions, reshaping their surfaces and altering their reflective properties. The dynamical interactions with Neptune and other bodies lead to resonances and migrations, which have implications for the solar system's evolution. Far beyond the Kuiper belt lies the hypothesized Oort cloud, a distant spherical shell of icy bodies extending up to a light year from the Sun. Though never directly observed, the Oort cloud is inferred from the orbits of long-period comets, which originate in this deep reservoir. It serves as the outermost frontier of the solar system's gravitational domain and represents a transition to interstellar space. The Kuiper belt and Oort cloud together form a vast hinterland, preserving primordial materials and dynamics that shaped our planetary system. Studying these distant realms expands our horizons, revealing the solar system as a dynamic, evolving structure rather than a static collection of isolated worlds. These outer reaches challenge our imagination and scientific tools, inviting us to venture farther, to discover the origins of the solar system's architecture, and to understand the forces that continue to mold the cosmic neighborhood we call home. As we venture beyond the familiar planetary orbits, and even beyond the distant Kuiper belt, we enter a realm shaped by the influence of the Sun's gravity, stretching outward into the vast interstellar space. This boundary, called the heliosphere, is a protective bubble carved by the solar wind, a continuous flow of charged particles emanating from the Sun at immense speeds. The heliosphere shields the solar system from the majority of cosmic rays and interstellar radiation, creating a dynamic interface where the solar wind meets the interstellar medium. The heliosphere's outermost region, known as the heliopause, marks the boundary where the outward pressure of the solar wind balances the incoming pressure of the interstellar medium. Here, the Sun's influence wanes, and the vast, cold expanse of space between stars begins. The Voyager 1 and Voyager 2 spacecraft, launched over 4 decades ago, have traveled beyond this boundary, sending back humanity's first direct measurements from interstellar space, revealing a silent yet vibrant frontier filled with energetic particles, magnetic fields, and faint cosmic winds. Within this grand expanse, the solar system is not isolated, but moves through the galaxy, orbiting the Milky Way's center at an average speed of about 828,000 kilometers per hour. This galactic journey spans roughly 225 million years per orbit, carrying the Sun and its retinue of planets, moons, asteroids, and comets through different interstellar environments, dense clouds, stellar nurseries, and sparse voids that can subtly influence the solar system's outer boundaries and influx of cosmic material. The gravity of the Sun extends far beyond the orbit of Neptune, reaching into the distant Oort cloud, a hypothesized spherical shell of icy bodies believed to be the source of long-period comets. These comets, when nudged by passing stars or galactic tides, travel inward toward the Sun, becoming spectacular visitors in the inner solar system. The Oort cloud thus acts as a cosmic reservoir, preserving the frozen relics of solar system formation, poised on the brink between solar dominance and the vastness of the galaxy. The interactions at these boundaries are subtle, yet profound. They influence the flux of cosmic rays reaching Earth, which in turn can affect planetary atmospheres and even climate over geological timescales. They also govern the transport and dynamics of interstellar dust and gas entering the solar system, materials that seed planetary atmospheres and contribute to the complex chemistry that underpins life. The solar system, with its planets, moons, rings, asteroids, and comets, is but a small oasis within this vast cosmic sea. Yet this oasis is dynamic, shaped by forces both internal and external, ancient and ongoing. Understanding the heliosphere and the solar system's galactic environment provides perspective on our place in the universe, revealing a delicate balance between cosmic forces that sustain life and the ever-changing dance of celestial bodies in space. As humanity's gaze extends beyond Earth, beyond the planets to the edges of the solar system and beyond, we begin to grasp the true scale and complexity of our cosmic home. We realize that the solar system is a vibrant, interconnected system, one that connects the intimate story of Earth to the grandeur of the galaxy and the infinite tapestry of the universe itself. Within the solar system, the interplay of gravity, light, and matter gives rise to spectacular phenomena that captivate the imagination and deepen our understanding of cosmic dynamics. Among the most striking of these are the planetary rings, delicate luminous bands encircling some of the giant planets, composed of countless particles ranging from microscopic dust to sizable chunks of ice and rock. Saturn's rings, the most iconic and expansive, stretch across hundreds of thousands of kilometers, shimmering with icy brilliance. These rings, though appearing solid from afar, are actually a vast collection of individual particles, each tracing its own orbit around the planet. The rings are structured into distinct bands and gaps, sculpted by gravitational interactions with Saturn's moons, known as shepherd moons, whose gravity confines and shapes the rings, creating waves, ripples, and sharp edges. The origin of Saturn's rings remains a subject of scientific inquiry. Some theories propose they formed from the debris of a shattered moon or comet, while others suggest they are remnants from the solar system's formation, constantly renewed by ongoing collisions and gravitational processes. The rings are surprisingly young in cosmic terms, estimated to be only a few 100 million years old, indicating that planetary systems are dynamic, ever-changing environments. Jupiter, Uranus, and Neptune also possess ring systems, though far less prominent than Saturn's. Jupiter's faint rings consist mainly of dust particles, likely generated by micrometeoroid impacts on small inner moons. Uranus's rings are dark and narrow, with unusual sharp edges, while Neptune's rings are clumpy and incomplete, possibly due to the gravitational influence of nearby moons. These rings not only offer visual splendor but serve as natural laboratories for studying disk dynamics, which have parallels in protoplanetary disks around young stars where planets form. Observing ring behavior deepens our knowledge of processes like accretion, collision, and orbital resonance, fundamental mechanisms that shape planetary systems throughout the universe. Beyond the rings, solar system dynamics unfold in myriad ways. Planetary orbits governed by Kepler's laws, tidal interactions between moons and planets causing geological activity, and resonances leading to orbital stability or chaos. The elegant balance of these forces has led to a system that, over billions of years, has maintained relative harmony despite a tumultuous past, filled with collisions and migrations. Our understanding of these dynamics continues to evolve, propelled by increasingly sophisticated telescopes, spacecraft missions, and computational models. Each discovery reveals new layers of complexity and beauty, reminding us that the solar system is not static, but a living system, its motions and interactions ongoing narratives of cosmic evolution. In contemplating these celestial dances, we are drawn to reflect on the forces that govern not just planets and moons, but the very fabric of space and time, connecting our small world to the vast, wondrous cosmos beyond. The moons of the solar system, orbiting their parent planets like faithful companions, are worlds in their own right, each with its own story, character, and mysteries. From tiny irregular fragments captured by gravity to massive bodies rivaling planets in size and complexity, these satellites enrich the tapestry of our cosmic neighborhood. Earth's moon, our closest celestial neighbor, is a witness to the solar system's violent past. Its cratered surface and vast basaltic plains, or maria, tell tales of ancient impacts and volcanic activity. The moon's synchronous rotation, always showing the same face to Earth, has shaped our tides and perhaps even life itself by stabilizing Earth's axial tilt. Lunar exploration has yielded invaluable insights into planetary formation, revealing clues about the early solar system's chaotic environment. Jupiter's retinue boasts some of the most fascinating moons, especially the Galilean satellites, Io, Europa, Ganymede, and Callisto, discovered by Galileo Galilei in 1610. Io, the most volcanically active body in the solar system, is a fiery world sculpted by intense tidal heating from Jupiter's gravity and interactions with neighboring moons. Europa's icy crust conceals a global ocean, making it one of the prime candidates in the search for extraterrestrial life. Ganymede, the largest moon in the solar system, possesses its own magnetic field, an extraordinary feature for a satellite, hinting at a differentiated interior and potential subsurface ocean. Callisto, heavily cratered and ancient, offers a glimpse into a less geologically active past, preserving a record of billions of years of cosmic bombardment. Saturn's moons are equally captivating. Titan, larger than the planet Mercury, boasts a thick nitrogen-rich atmosphere and liquid hydrocarbon lakes, resembling Earth's early conditions. Enceladus, smaller but no less remarkable, jets icy plumes from its south pole, signaling subsurface oceans heated by tidal forces, making it a hotspot for astrobiology. Uranus and Neptune, the distant ice giants, have numerous moons, many named after characters from literature and mythology. These moons exhibit diverse geologies, from cratered surfaces to signs of past geological activity, reflecting the varied conditions in the outer solar system. Triton, Neptune's largest moon, orbits retrograde and shows evidence of cryovolcanism and a tenuous atmosphere, suggesting it was captured rather than formed in place. These moons challenge traditional notions of habitability, revealing that conditions suitable for life may exist beyond the Earth-like environments. Their complex interactions with their parent planets, internal heating, and diverse compositions make them compelling targets for future exploration. Through the study of moons, we deepen our understanding of planetary systems, the potential for life beyond Earth, and the dynamic forces shaping celestial bodies. Each moon is a world with its own secrets, waiting to be uncovered by human curiosity and exploration. As we reach the outermost reaches of the solar system, our gaze turns to the distant and mysterious dwarf planets, icy bodies that defy traditional planetary definitions yet hold profound significance in understanding the solar system's diversity and history. These worlds, scattered throughout the Kuiper Belt and beyond, embody the remnants of the solar nebula, the primordial disk of gas and dust from which our planetary family emerged. Pluto, once the ninth planet and now the archetype of dwarf planets, captivates with its complex geology and atmospheric dynamics. Beneath its icy surface lies a differentiated interior, with a possible subsurface ocean that challenges assumptions about small, cold worlds. Its orbit, inclined and elliptical, dances at the edge of the Kuiper Belt, crossing paths with Neptune in a celestial ballet governed by gravity's subtle hand. Eris, discovered in 2005, sparked a re-evaluation of what constitutes a planet, prompting the International Astronomical Union's definition and the introduction of the dwarf planet category. Eris is slightly more massive than Pluto and orbits even farther from the Sun, its surface covered in a reflective layer of methane ice. The presence of such bodies underscores the diversity and complexity of the solar system's outskirts. Haumea, with its rapid rotation and elongated shape, stands out among dwarf planets. Its surface is rich in crystalline ice, and it possesses a ring system, rare among small bodies. Haumea's collisional family, a group of objects sharing similar orbits and composition, points to a violent past that shattered a larger progenitor. Makemake, bright and distant, displays a surface dominated by methane and ethane ices, with a tenuous atmosphere that waxes and wanes as it orbits the Sun. Its discovery added another piece to the puzzle of the Kuiper Belt's composition and dynamics. These dwarf planets, though small and remote, provide crucial insights into planetary formation and migration. Their varied characteristics suggest complex histories of collisions, differentiation, and resurfacing. They bridge the gap between planets and smaller solar system bodies, highlighting the continuum of objects orbiting our Sun. Exploration of these distant worlds remains challenging, yet missions like New Horizons, which flew past Pluto and Arrokoth, have revolutionized our understanding. They reveal a solar system still vibrant and evolving, with icy worlds harboring secrets of organic chemistry, geological activity, and perhaps conditions conducive to life. The solar system, from Mercury's scorched plains to Neptune's frozen storms, and onward to the faint glimmers of dwarf planets, is a tapestry woven from diverse threads: rock, ice, gas, light, and gravity. Each world, large or small, contributes a verse to the grand cosmic poem, inviting us to explore, understand, and marvel at the infinite wonders of our celestial home. As our journey ends here, the quest for knowledge continues, propelled by human curiosity and the timeless desire to comprehend the universe in which we live.